Yeah, like that for notification was for another class.
Oh, okay.
Yeah.
Yeah. So, but that's okay. So let me go back to this slide here. That was the app that I was working on during. Okay, so I'm gonna show you. So we actually got two students in this class who went. Jesse, right? So Jesse and Cody, went to SF Hacks over the weekend, and I do want to talk about it because I think if anyone, if you should go to at least one of these. Okay, if you have never been to one, just look up, what is the next one. They do have ones local in Sacramento as well. So it's a hackathon, okay? And unlike the Friday event that I also advertised, it's not about hacking in the sense of security. This is about hacking in the sense of let's make something, okay? Let's make something that is useful and valuable to some business or at least to some people. So it's hacking in that sense, and it is called a hackathon. If you look up the word hackathon, okay, and Wikipedia has one, and we can just kind of read off this one here. So a hackathon is also known as a hackaday, hackfest, or code fest. It's basically a 24-hour thing, and sometimes longer. I cannot imagine how it can be longer, but it's a 24-hour thing where you have just exactly 24 hours, okay, noon to noon, the next day, to come up with something, okay, and you basically at the end of the whole thing you showcase the sponsors, and you showcase whoever is funding the event of what you have made, why you made it, what you made it out of, and so on and so forth. Okay. The purpose of a hackathon is kind of multi-purpose. Okay. So one purpose is quote unquote educational. They want to promote students to participate and learn how to code. Okay. And coding is not the only thing. I think this time they got a UI/UX award. Okay, so if you don't code too much, but you're very good at designing user interface, well, they got one award this time just for UI/UX. Which team won that one? I cannot remember.
I forgot to.
Yeah, but anyway, someone got a prize, got awarded, because of the user interface design. Okay, they got one for hardware, hacking. So some team used like hardware stuff, to um, their project. So this is a hackathon. Um, so basically, it's very open ended. It's not like a programming contest. Okay, I have gone to programming contests. They will give you very specific problems to solve. Okay, they will tell you this is the problem. Okay, this is the input. This is what the output should be, and they will describe the output in a very precise and mathematical way. Okay, so the problem is how do we go from the input to the output? How do you come up with the algorithm? That becomes the tricky and the difficult part. That's a very traditional programming contest. This, hackathon is open ended. I mean, they didn't even tell us, even guidelines like, oh, try to do something to blah 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 blah. Okay, they only tell you what the awards are, and then it's like, okay, go, do whatever you think will win that prize. That's kind of the nature of a hackathon. Are there any questions about a hackathon or hackathons in general? No. Okay. So the other thing that's interesting about the hackathon, remember I said it was multi-purpose, and one was to promote people to study and learn how to write code and develop. The other one was this is actually also a hiring event. Okay, Google was there, Macy's Tech was there, Twilio was there, and who else was there? Do you
I
remember?
think also some people like I think it was.
It should say on the website.
I might be able to find the sponsors from the website. So sponsors, there we go. Oh, right, Weight Watcher.
Yeah.
So These are the sponsors. Walmart had a table. Microsoft did not show up. Yep.
Did you already start the OBS stream?
Yes, I did.
Okay.
Yep. Even though this has nothing to do with 440, I think it has to do with, the higher level goal that you guys have. Okay, who amongst you want to just pass this class and that's it? You just go back to your usual life and. So assuming your ultimate goal is to become a developer or make a living in high tech slash software development slash all of these things, I think this is actually as relevant, if not more, than the content of this class. Okay, knowledge is one thing, but the bigger picture is the other one. Macy's Tech, okay, and you know that Macy's have been closing stores, right? Okay, all over. But they're moving their stuff, into the cloud. So they were actually expanding. Macy's Tech was actually hiring people, and it's interesting, right? I mean, you would not expect that, and they're actually in San Francisco as well. So Macy's Tech, had the headquarters is actually inside, San Francisco. Kind of interesting. The other companies, some of these you know, and some of these you do not. Okay, Google, we don't have to say anything about that. Walmart, we don't have to say anything about that. Weight Watcher. Why would Weight Watcher be in a hackathon? Other than just telling people, don't eat all those pizzas, right? Because they, you go there, they will feed you. Okay, they feed you lunch, dinner, breakfast, all the snacks in between and whatnot. So what do you think they fed you? Costco pizzas. Now, of course, the interesting part, okay, and Cody and Jesse can comment on this one, was you know how big a Costco pizza is, okay? Kind of like just like a large, or slightly larger than a large pizza. Usually it's cut into 12 slices, okay? And they want people to line up. Now we are talking about 300 people. I can show you pictures of the event. So we got about 300 college students lined up, okay, to pick up these pizzas. They give you 2 slices, which is 1/6 of an entire pizza, okay? And they tell you, okay, that's all you can get, okay, because we want to save some, make sure that everybody gets some. And then how long did they wait before they let people go for seconds?
About 30 minutes.
About 30 minutes, so the pizza became kind of cooler. Then they let people to get extras, like 2 more slices, okay? And then at the end, I think after maybe an hour or so, then they started to beg people. It's like, oh, we still have 30 boxes of pizzas. Please come and eat these pizzas.
There was more than 30 boxes.
Huh?
I think there must have been about 100.
50 additional pizza boxes that were unopened at that time. So so all of these students basically tried. They ate throughout the night, in the morning, and then and then some even lasted until the whole thing was finished, and there was still leftover pizza that they had to toss into the trash can.
Why?
And they were so concerned that they wouldn't have enough to begin with. So that that's kind of besides the point. But that's the idea is they will feed you pizza basically. And for breakfast, what do you think they will feed you for breakfast? Costco muffins.
Yes.
And then they end up with, guess what? Boxes and boxes and boxes of extra muffins. So I can kind of imagine why Weight Watcher would have a presence over there, because they just want to tell people, don't eat all that pizza and muffins. Start trying to be healthy. But that's not the reason why they were there. Do you remember why they were there?
It was more to find people to work on their I think website and stuff.
Right. So it was a company who had their own presence, doing fitness and whatnot. They figure out how to motivate people to do exercise, like rewarding and stuff like that. That's basically what Fitbit is. Okay, they give you all kinds of prizes, boards and whatnot. All kinds of numbers, graphs and whatnot, to basically help people to understand which way they're going, how to get there, and so on and so forth. So there was this guy who started the company. It was a small company, and eventually they got absorbed into Weight Watchers. So he was one of the speakers, at the beginning of the event. So that was kind of interesting. What I want to do is to kind of share some pictures, that I took, so that for those of you who have not been to a single hackathon, you understand what it is. So let me get to gallery and screen copy. No, that's not it. Well, actually, okay, I take it back. It was one of the things I want to show you. This was where we were. Okay, this. And by the way, this is my avatar. So if you see that on campus, don't take that gym. Leave it alone. So this was where we were. This is the main campus of San Francisco State University. We were at the very south edge of the campus, and you can see it's a Pokemon Go dead zone. There were no gyms, no stops, no Pokemon, nothing. So we can all focus on the program. Okay. So this is kind of, I'm not very good at selfies. Okay. Okay? But this is kind of the beginning, where people kind of came in and they were checking out the sponsors. The sponsors had tables on this side. So it was very kind of social, a lot of interaction between the participants and the sponsors. The sponsors really want to talk to people because they want to get people they want to hire people. Because right now, the Bay Area is completely drained of talents. Okay? The other thing that was really interesting, I didn't take pictures of that, was around the campus of San Francisco State University. It's not really downtown. It's not some place where you would expect a lot of people to park, especially on a weekend. Okay, so what we found was for every 4 cars parked on the street, there's an RV. It's like car, RV, car, RV, car, RV. Okay. And I lived in San Francisco for 2 years or so in the 80s, and I have never seen this kind of concentration of RVs. Why do you think they got so many RVs?
Travel the world.
Huh?
Yes, you don't want to have your own car.
You cannot afford to live in San Francisco, but that's where the jobs are. Okay. I bought this. This is my first ever Apple product that I bought because I forgot to bring my power supply. So I had to buy something, and Target only has a 30-watt power supply. And so I had to stop by an Apple store. So do you think if you work for Apple store, as a clerk, as a retail person, do you think you can afford to live in San Francisco?
No.
Not now, right? So how are you gonna go to work? If you live in Tracy, right? If you live in Vacaville, how do you get to work? Are you gonna drive?
Take the plane.
Yep, exactly. So you ask your grandpa, okay? Hey, I haven't seen you, using that RV for at least 10 years and it's rotting away. Can I borrow it?
Indefinitely.
Huh?
Can I borrow it indefinitely?
Well, grandpa would sell it to you, right? Okay, 20 grand and it's yours. Yeah, but people they were basically living in these RVs so they can work in San Francisco. Okay, you can look up the median pay for a software developer. Okay, it's not that much money. Okay, you look up the rental price in San Francisco. You compare that to the median pay of a software engineer. Even if you are a software engineer, you cannot really afford to live in the city. It's that expensive. Okay. Now they can quote, oh, but these people are making $200,000, $300,000. They are not entry level employees. Okay, those were like supervisors, project managers, and whatnot. So those people were making enough money to live in the Bay Area. But when you're just starting off, you won't be able to afford to live in the city. Okay, so more pictures. Come on, show and tell. All right, so this is after the event has started. Basically, they got these folding tables, and it's a big building, kind of like industrial building, like a warehouse. Um, there were maybe about 60-ish tables, and each table, for one team or so, and 4 people to a team. So you can kind of imagine how many people were there. Maybe 200-300 people, because there were some tables along the edge, that are not in the center, and some people who came late basically were working on the floor. I mean, they didn't have any table. They had to hijack the tables from the sponsors, because the sponsors all left, after a little bit of time, because guess what? They have to go back to work. They are not paid to stay in a hackathon to talk to students. Okay. Besides, once it started, people were just concentrating on coding, and very few people would actually talk to the sponsors at that time. That's a long line for pizza, by the way. Back there, I can see Tristan over here. He's smart. Whenever they announce, we have food, or when he see the food coming in, he would go line up. Let's see. So this is a very short video that I took, just a 360. People were still lining up, and most people are eating at that point. We got sponsors still, there, at that time. Yeah, I'm gonna stop it here because I forgot to turn it off before I put it back into my pocket. So you might get motion sickness if I don't stop it at this point. But that's kind of a 360 of how busy the event was. I think some of you went to the SAC hackathon, right? One of the Sacramento hackathons. Who did? No one.
No, I heard of it, but never.
Yeah, but I talked to someone who also went to the Sacramento one, and they said it wasn't quite as many people. This is in San Francisco, and San Francisco State University was sponsoring this, so I would guesstimate about 80%, 70 to 80% of these students were San Francisco State University students. I could kind of tell, because by the time it got to 11 p.m., midnight or so, a whole bunch of people left, because they got dorms or they live somewhere in San Francisco. They just kind of go home and sleep, right? And then Cody, fell asleep at the table, at a very, unhealthy position. So he got a stomach problem after that, right? Yeah. I didn't sleep much. I just kind of dozed off. I don't know what you guys did. Did you guys get a chance to sleep on the floor? At the table? Okay. Yep. But a whole bunch of people left because they are just right next door. Because the where this was held, it was right next to the dorms of San Francisco State University. So I think some of the students just kind of walk home, to sleep. So that was kind of interesting. Let's see. So Devin and Tristan, they were working on some coding, at the time. This I can tell from the food on the table. This is shortly after lunch because they served burritos for lunch. Yep, it's kind of interesting. Let's see. This is the other team from ARC. Huh?
What did they make?
They made an app, an iOS map, in conjunction with Instagram. Was it? No, Snapchat. To create a virtual sticker, AR sticker, in a picture. Is that kind of what you guys did? Yep. So it's really open-ended. They let you do just about anything you want. If you want to do back-end server stuff, do back-end server stuff. If you want to do web stuff, do web stuff. If you want to do app stuff, do app stuff. If you want to do robotic stuff, do robotic stuff. So the idea is completely open-ended. Showcase what you can do, so they can evaluate whether they want to hire you or not. I really think that's kind of the unspoken purpose of these hackathons. So this is kind of like another view of the whole thing, and people were just really, really busy working. I don't remember why I took that picture. So there's a stage in the back here, and the sponsors got on stage and talk about stuff. And time has passed, so there's still chips. So it's still before dinner time, because by dinner time we would have pizzas. This is the judge. Okay, this is one of the judges who judged the teams. So this particular team did not quite finish the project, even though they got a good start, got a lot of stuff done, but they did not quite finish. Okay, so now is a good time to talk about, if you want to go to a hackathon like this, okay, how do you prepare yourself to go to a hackathon? Why would you want to go to a hackathon?
For fun.
It's kind of fun, okay? If you have a team of people, like a bunch of buddies, and you want to just crash and do some coding and figure out what these hackathons are all about, it's really kind of nice, okay? Just make sure you don't have a midterm on Monday. That would not work out very well. Right, Cody? If we had a midterm today, that would not be very good timing.
I think you'll be nice enough to move it.
But you're taking not just one class, are you?
No, you're switching class.
Yep. So the other thing that is kind of interesting is you really want to know how to use GitHub, okay? Because when people, let's say you got something that catches the attention of one of the sponsors. They come talk to you, and they want to evaluate whether you'll be a good addition to their company or whatnot, okay? And they ask you, okay, so how does the team share code, right? Because you guys are all working on the same program, and you say, here's my thumb drive, okay? We share code using a thumb drive. Guess what? They're not going to hire you. Because you want to use a revision control system or some official way to kind of manage code sharing and revision. Did you guys use GitHub? Yeah. So most of the teams use GitHub or one form or another, some kind of revision control software for dealing with that problem. Okay, so they want to be able to see that you know how to work in a team environment using the right tools to share and manage your code, revision control your code. So that's one. And what is this link? Oh, DigitalOcean. So many teams also work on backend stuff. When I say backend stuff, I mean it's a service in the cloud, in the web. Okay, that's kind of like a big thing. If you look into Google, if you look into many companies that with a forward-facing company like Lyft. Okay, so you guys have used Lyft in one way or another, right? As an end user, but Lyft also has a backend. Or an API. Okay, does anyone want to explain to me what an API is in the context of a cloud resource? Okay, one wants to. I know some of you already know what it is. You want to try? No? Okay, I got the screen just for that. Just give me a moment to find it. So it is moments like this, when I kind of have to go back and promote my the use of tab outliner or something like that really helps to find out which tab is what, right? So I can now say okay, this is for Twilio, which is one of the back-end companies who had a presence over there. So when I talk about back-end, I am talking about code. Do you guys want to see C# or Python or JavaScript code? Pick one. Huh? C#? Okay. So this is the C# code for using the backend of Twilio in order to send a text from a computer in the cloud to a text number. Okay? So that's what I mean when I talk about an API. It's an API to utilize a cloud resource. Okay, and that's a big thing. So now you know what a backend is. Where are you going to run this software? Okay, on your laptop, computer. It's on a server. Okay, it's on a server in the web. Okay, in the cloud. So how are you going to host something in the cloud? The old way was, okay, go buy a cheap computer, pay a little bit more to your ISP, get a static IP. You don't need a static IP, but that's one way to do it. And then register the domain name, get the DNS entry to point to your IP address. Then you have some kind of web presence. Would you go that route if you want to start up a new company and you're starting to offer some kind of web or cloud resource to people? Why not?
Something happens to the computer.
What if something happens to the computer? Very good. Okay, that's a good question. But let's just say you got a whole stack of old computers that are your backups, right? What else? What can go wrong in that picture? Power fail, right? Your ISP fails, right? What if you got hacked? Okay. What if you forgot to install the latest updates to stop a particular vulnerability from being utilized or abused? Okay. So there are lots of stuff related to maintaining a server that you have to put in to keep something up and running. Okay. Now I'm not saying that you guys don't know how to do it. I'm just saying that it's a lot of work. Okay. If you start a company and you want to focus on just coding, what matters, you don't want to spend too much time to maintain your own server because that's just not worth it. So what do you do then? Go ahead.
No, go to DigitalOcean.
DigitalOcean is one place. Google Cloud Platform, AWS, Amazon Web Service, and I'm pretty sure there are more competitors in that market, where they do not just give you a virtual machine. Okay, if they give you a virtual machine, then you can save yourself from power fails and networking issues. But somebody can still hack into your machine. You still have to perform all the updates. You still have to monitor, traffic and stuff like that. So what they're doing now, at least with Google, is they have Google App Engine, and I'm pretty sure Amazon has a similar product, DigitalOcean has a similar product, and so on. So what they do is they create an environment for your app to run. Okay, so you have to say, oh, I want to use Node.js. Okay, so they will install Node.js and the basic tools. Then the rest is up to you. Okay, you want additional packages, run npm. Okay, to install additional Node packages. You write your code, and when it's time to, you can test your code using their sandbox platform. When it's time to deploy, and you run a single command, then your app will now be running on a forward-facing server, or I think it's just a container, and you can now start to serve the requests coming in from the internet. Okay, so what is the advantage other than not having to maintain your server? What do you think? So you will start a company, right? So initially you only got 10 clients. Okay? Network traffic was kind of slow, you're not using a whole lot of storage, no big deal. But let's say your marketing manager is a wizard, okay? He or she was able to grow your business tenfold within a week. So now you got 100 customers, right? So what's going to happen to your app? What's going to happen to the platform that's running your app? Get more traffic, right? So with more traffic, if your instance running on the web is static, then it gets slower and slower. Then your customer becomes 50, then 25, and then back to 10, which is not a good thing to have, right? So what Google Cloud Platform or Google App Engine and many other products can do is they can auto scale, which became our problem later on. They can auto scale. So they can monitor an instance and go oh, if the load average of an instance is beyond 50%, okay, then they will spin up a new instance without you having to do a single thing. Move a copy of your app to the new instance, and now you have two instances serving the internet. And it's done dynamically. But you don't pay for all that processing power and all the resources unless you're actually using it. So when traffic goes down, they will cut down some of the instances. They will just kind of shut down the instances also. So it auto scales in a very nice way. Yep.
Does it provide like more data to them as well?
Yep. Well, since it's Google, it collects all kinds of data and it gives all kinds of plots to you. I don't know to what resolution. So if you want to know where the requests are coming from, I'm not sure whether to keep a log of that and give you like a heat map of the country, so you can kind of tell how much requests is from the East Coast to or the West Coast. Yep.
So what would it pay to like to free it? Just try for free.
You can try for free. So if you're not affiliated with anything, you can sign up for your own account. All you need is a Google account to sign up, and I think you need your credit card as well, because just in case they want to know how to get money, right? But when you sign up, they give you like a $300 credit. So until what you have used is exceeding the credit amount, you won't be incurring any actual charge on your credit card. And $300 is a lot if you're just testing and playing with it, because they only charge money for what you use. So if you're testing without deployment, they don't charge you anything. It's only the deployed instances that will start to charge money. If your database is small, it's like really insignificant amount of money. So it really is a very scalable approach where $300 goes a long way if you're only using it for educational purposes. If you're Walmart, obviously that $300 is going to disappear like that. So does that answer your question? Okay. So that's kind of interesting, and this Twilio was one of the sponsors. Other than people who went to the hackathon, does anyone know what is Twilio? Yep.
Like a messaging app kind of thing?
It's a messaging back-end thing, right? So what they do is you can sign up to Twilio. Once again, they also offer like a certain amount of credit, right? You can do it for free for a little bit.
Give it like $15.
They give you $15 worth of service, right? So what you can do with those $15 is you can sign up for an SMS slash voice number, okay? And you can choose the area code. So you can just say, okay, I want to have a 916 number. Give me one, okay? And that number can receive SMS text. Okay, you go like, okay, then what? Well, when that number receives SMS text, you can then configure Twilio to send a post request to a URL that you can choose. Is that okay? So that hooks up to whatever app you're running using Google Cloud Platform, using your little server in your room, or using AWS, whatever. Okay, but then you have control over what to do with that SMS message. And why would that be useful? What kind of SMS commercial utilization can we think of?
So could you have it like you send a text to whatever number Twilio gets, and then it kicks off some service on some other server that you would have set up, kind of thing?
And then what do you do with that SMS message?
I don't know. Kick it off to do whatever, send emails or something.
Or control the lighting of your house, maybe? Right? Because there are still many people who do not want to use a full up smartphone, but they do have SMS access. Okay, so you can actually start to offer services based on only SMS. Do you need 4G to get SMS working? Exactly. So some people may not want or have 4G connection. They only have like the basic mobile service, which is less costly in the United States. Okay, data costs more, which is exactly the reverse in some Asian countries. In Hong Kong, it's exactly the opposite. Data is like, you can get as much as you want. The moment you say, I also want voice, oh man, it gets super expensive. I don't know why, but that's the case. But anyway, but in this country, there are places and people who just want SMS and basic, phone access without the 4G or the 3G and now the 5G, support. Now we can say, oh, those people can now utilize, AI technology now, okay? Because you can now text, stuff that is not going to a person, but it's going to a server. The server can now perform whatever operation you're requesting. Is that okay? So, can you use SMS right now to get a lift? Does anyone know? Does Lyft have an SMS interface?
Yeah.
It does?
Yeah.
Okay. So let's say they don't have it yet, okay? They don't have a web interface. So it would be a nice thing for a company to go in and go like, okay, I know how to talk to the Lyft backend, their API. I know how to use Twilio. So now you can offer a service so you can text for Lyft. Is that okay? So they're looking for people who have, I think a lot of companies are looking for people who can do this kind of back-end or API type program. Mobile app is another thing that was kind of big, but I don't know how many teams actually used mobile app. One team was kind of interesting. They were using a TI-84CE. What was the name of that project? 84 cheat or cheater 84 or something like that. Yeah, cheater 84. So they were programming a TI-84 to do what?
They had they're able to use it, have it use Facebook and take pictures and basically just cheat on your test basically. So to look up answers, use Google and all that.
Yeah, but they were able to figure out how to use 84 and interface to the back end or the API of many of the services that we just talked about.
Yeah.
Which is kind of interesting because it showcases the students understood the back end well enough to do it. Now, many of these languages may not be supported on an TI-84. I don't know about the TI-84CE, which is kind of the current flagship of that line of calculators. But the older ones were only programmable using BASIC, and I don't see BASIC here. So that means you have to use a different programming language, come up with your own subroutines or methods, depending on whether it is object oriented or not, to talk the lowest level of the API. Okay, and being able to demonstrate that skill is a big thing too. So what do you think is at the lowest level of these APIs? I mean, at this point, you just go like, oh, if I know how to do object-oriented programming, I should be fine, because it's just a class, saying .create to create an object, that is a message, and you just pass a few parameters and done. Okay, that's no big deal, right? Why is this difficult to do? What if you're doing trying to do the same thing with a programming language that is not listed here? What are you gonna do? Then you have to do this. This is curl, which stands for command line URL, I think. Does anyone know what the C stands for? I think it's command line. But basically, this allows you to specify a HTTP request, and you can also specify the parameters that go into the request. So all the API that I just talked about, how to use your Lyft, or Twilio, or Google Documents, or Google Calendar, the so-called API really is HTTP requests, how you format it, how to specify the parameters, what is going to be the reply from those requests. Usually it's a JSON, a JSON type of string, and how to parse it, what each parameter or each attribute means, and so on and so forth. Okay, so at the very lowest level, this is what API really is. Okay, it's a request and a reply, request, reply, request, reply, and so on. Now, so what is difficult about this whole thing? Looks pretty simple, right? It's just a whole bunch of text processing. It is going to break the paradigm that you guys have all learned in CISP360, right? What did you learn in CISP360? How do you run the program? Click that one button in code blocks, and the program runs to completion. You look at the output, everything looks good, you're done, right? How do you think this works? You send a request, right? Do you think you get a reply right away? No. It might take 5 milliseconds, 10 milliseconds, 50 milliseconds for the reply to come back. So while your request is sent, but the reply is not here yet, what are you doing? So if you only think about what you have learned in CISP 360, 400, even 430, you'll be stuck in a loop. because you will have a loop that says while not reply received, do nothing. You're busy waiting. You keep asking that stupid question. Do I have a reply? No. Do I have a reply? No. Do I have a reply? No. How many times do you think you can ask that question in 20 milliseconds? No. You cannot do it a whole lot, but your program can. Your program running on an i7 processor, at 4 gigahertz or whatever, can ask that question possibly millions of times within 10 milliseconds. Okay? Why do you think that's not such a good idea?
Resource for processing something else.
Yes, and when we talk about processing resources, we are not just talking about processing resources. We are also talking about heat dissipation. Because guess what? At the headquarters of AWS, Google Cloud Platform, DigitalOcean, and whatnot, the ultimate limitation of how much processing power they can pack within a certain square footage is based on heat dissipation. How much heat can you extract out of a building? That limits how much processing power they can pack into that space. And I think somebody, did you? No? Somebody told me about the next Microsoft data center is going to be under the sea, because they can then use ocean water for cooling purposes. So cooling is a big deal. If you write an app that busy waits for an answer, you might get kicked out. Google Cloud Platform says, you are wasting our heat. We don't want your business anymore. Go away. So what do? You send a request and you're waiting for an answer, and you don't want to busy wait. What do you do? Huh? You can use different threads, okay? So yes, you can use multi-threading, which can be done using C and C++, but it's a lot of work, okay? So now you're getting into programming techniques that are kind of unique to some of the programming languages, like JavaScript or Node.js has what we call a promise. So it allows you to specify when the reply comes back, this is what we need to do. So it allows you to break up these what we call asynchronous sessions of using resources and specify this is what we send. When we get a reply or an error, this is what's going to happen. So it's no longer sequential programming that we were taught, for all of these classes. Does it make sense? Okay, that's what they're looking for. Okay, I was just talking to students in my previous class. I'm giving them two scenarios. Okay, so let's say you're graduating from Sac State, UC Davis, or whatnot. Okay, doesn't matter which one it is. So imagine two students, went up to trying to come up with an example. Let's say a taxi company. Okay, who was trying to improve their web ability to do stuff. Okay, to get a taxi because they need to stay competitive with Lyft and Uber. Does it make sense? Okay, so the yellow cap, is recruiting people to work on their team to deal with to use web services. One student comes out and say, "See, I got straight A's. I'm on dean's list every single semester. Okay, I'm in these clubs, blah 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 blah, and I ace every single class. Okay." As an interviewer, I think most interviewers will go like, "Well, this is pretty strong. I like it. So I will get back to you later." That's what they're gonna do. Okay. Next student comes in. Okay, not quite straight A, 3 or so. Okay, 3.0 GPA. But at the same time, the other student says, "Yeah, but I have also gone to at least 2 or 3 hackathons every year. Okay, I wrote this app and pull out the code in GitHub. Okay, pull up the code and show. See, I'm using the Twilio API to order Lyft service, and I'm using AI to look at the face of a person. So if that person is sad, we'll automatically order Lyft to a bar." So depending on the facial expression, maybe we'll go to a bar, we'll go to a restaurant, we'll go get sushi or whatnot. Okay, but basically you have a mental health helper, based on Lyft, based on AI, and so on. Okay, course, this is a crazy app, right? And you show the code, you explain the code, right? This is the programming language that I use. This is Node.js. I know how to use the promises and so on and so forth. You're hired on the spot. Don't even go to the next table, okay? Just follow me to work. Because they don't want you to talk to the person at the next table, because otherwise you'd be hired there. I think this is the scenario, okay? I cannot promise you, okay? So next time when you graduate from UC Davis or Sac State and this doesn't happen to you, don't blame me. I'm just running off of an imaginary scenario. But I think that's kind of resemble what's happening, is they're no longer looking for people who are academically very strong, but have not been able to demonstrate real work experience and problem solving, and coming up with ideas. I can see a decrease of those emphasis in terms of hiring, and an increase of, can you think of something that's novel? Can you think of creative ways of using something? Can you work with people? Do you know how to use the proper tools for actual development? They're looking more into those directions than, say, 30 years ago. The other thing that was kind of interesting in this trip was, when I could tell people that I was, because sometimes they wonder whether you're a student or not, because I'm older. So I can tell them and go like, well, I was a student here 30 years ago, which was actually true. I was actually a San Francisco State University student 32 years ago. But 32 years ago, that's a completely different story when it comes to hiring and what you need to kind of get into the industry. These days, it's kind of different. So if you have a chance to get to a hackathon event, I really strongly encourage you to at least go participate, find out what it is about. Okay, if this stuff here looks kind of foreign to you and you have no idea what this is, it's okay. And this is how you learn stuff. Okay, you go to a hackathon, you find out what kind of tools they want you to use, and then you learn about it. You just do all the learning on the spot, which is another thing employers really want to focus on these days. Is if I don't tell you textbook stuff, okay, if I don't give you a stack of books, can you learn on your own? And that's kind of like a really big thing too, with modern day employers. So that's kind of my little summary of my experience with SF Hacks. Just to finish this off, we can find out where is the next one. November?
There's also 1 second.
Well, then we have a hackathon in Sacramento. This is Eventbrite. So we got this one, March 30th. School of AI Health Hackathon.
There's one in Paris.
Hmm?
There's one in Paris in India.
They're all over the place too.
Short trip. Let's go class field trip there.
Yeah. Or go to Egypt.
I wish we could do that. Develop a successful healthcare tech startup business today. That doesn't look like a hackathon. Hmm?
Yeah, it's like
In 10 minutes, right? Yeah, but it's good to go to at least one of these. With if you go with a group of friends, it's even better. Just don't focus too much on the winning part, because it can be very competitive. It may not be very competitive. Just go and experience and learn. I mean, that's the bottom line. Any questions about all of this stuff? Other than, so why are you not teaching this stuff instead? Well, because the 4-year universities, they are still using C and C++, and we have to articulate with 4-year universities. So until they change and say, oh, we want students to use JavaScript, okay, we cannot change. If they keep saying we want students to know C and C++, we have to continue to teach C and C++. If they say we want our students to know about all the cisp440 stuff like probability and whatnot, and that's actually really important stuff too. we have to keep teaching that stuff because we are basically teaching the lower division classes of a 4-year university here. Right? I mean, if you check your assist.org thing, you're basically looking at a mapping between the classes that we offer and a lower division class at a 4-year university. So we are kind of limited in terms of what we can actually offer. If I start to teach JavaScript as a separate class that is not a part of your transfer degree, there won't be enough people taking that class, okay? Because it's out of the usual path of a transfer degree. So that makes it difficult to basically keep a class going. 'Cause I cannot start a class with like 15 people in class. So that kind of answers that question. Any other questions?
Where is that?
Hmm?
Where is that?
Where's? I mean, this one?
Yeah. Downtown.
It's organized by the Hacker Lab, so it's definitely legit. So help School of AI solve one of the world's leading healthcare issue. Okay. R Street, downtown. That's probably the headquarters of Hacker Lab too. It looks close to the headquarters. Sorry? Any other questions?
How much does it cost to attend? If it costs anything?
I think these are free. Yeah. Yeah, these are, it depends on the purpose of the event. Most of the time, if they get big sponsors like Google or Walmart or Facebook or something like that, it really is a hiring event more than anything else. It's cheaper for them to fund a hackathon than to actually go to a career day kind of event or to use their own HR to try to reach out to people. Yep.
For the events, do they usually have like already stations set up for you, or like for a SF hack that you went to, did you have to bring your own stuff? Or?
You bring your own stuff. So they give you the infrastructure, electricity, and internet access, and even that is marginal. Okay, I'll tell you why it was marginal in this particular hackathon. The Wi-Fi access was limited to about 1 megabits per second. So
that's if you're lucky too.
Hmm?
That's if you're lucky.
That's if you're lucky, yes, because we have a lot of people using it. The good thing was most students were San Francisco State students, so they got their own access to Wi-Fi. So the guest Wi-Fi was only used mostly by people like out of town or other students who were not San Francisco State students. So the second infrastructure they provided that was also marginal was electricity. You go like, electricity, marginal, how can that be? Well, they were connecting, yeah, go ahead.
One outlet.
Well, they were connecting so let's say we have power outlet all the way to one room, to one side of a room. So they were connecting power strips, and they were daisy chaining power strips. Okay. Yeah. They were daisy chaining power strips, which is not a very safe thing to do. Now, but think about it this way: most laptop computers these days are very power efficient. Okay, I can run this thing at maximum clock rate, and it only has a total TPD, thermal something dissipation. Basically, that's the maximum of power it can take. Okay, it can actually use. Okay, it's about 15, 20 watts or so for an i7 mobile processor. So combined with like RAM and your solid state hard drive, let's call that 40 watts. Okay, that's not a lot of power. Okay, it takes a lot of 40 watts to make up for the limit of one single plug. Yep.
Oh, and also there's only one power strip for 2 teams.
In our case, some tables were luckier, but in our case, we got one power strip for 2 teams, and one plug of the strip was used for daisy chaining to the next table. So of the 5 power outlets of that one single power strip, we only got 5 that are actually usable to us. Okay, now, if you plug in a normal normal Apple Power plug, it doesn't have this cable. It plugs in directly, which makes the next two power plug unusable. That's kind of the situation that we ran into yesterday. And then your team figured out how to daisy chain USB-C power. Did it work?
Not with mine, but I could.
Okay. Okay. So you basically power up one computer, and then you use one of the output USB port to plug in another USB-C connector to the next computer. So you can chain the power to one additional computer. And I was doing that with Devin's computer. It was interesting because it quote unquote worked. It actually recognized that. But because a normal USB port as an output from a laptop computer is usually limited to 2 amps at 5 volts, okay? So it was not enough to actually power supply my laptop computer, but it came close. So I only dropped like 1% every 30 minutes. And that's after I turned the maximum clock of my i7 processor to 400 megahertz. So it was running at 400 megahertz the entire time. The screen was at the dimmest level. And then the USB plug was almost, keeping up with it. So that's why I decided to go to Stonestown and get that Apple adapter.
Portable batteries.
Huh?
Gotta get portable batteries for those hackathons.
Yep. And then your team was time sharing the same power supply. Yeah, because USB-C can charge pretty fast, and with if you're just coding, you're not using a lot of power, so you can actually time share a power plug and keep everybody happy at the same time. But we had to resort to that sort of thing, at the event. I'm hoping the next one, won't have this kind of issue, but this time we did. Any other questions? So that answered the question about the infrastructure.
Yeah, because an ARC, I came to the one here too, and they had it all set up for us. And
Uh-huh.
Raspberry Pis.
Oh, you mean the Friday?
Yeah,
the Friday security one.
Yeah.
Right. Yeah.
They had stations for everyone. So
Yeah. Raspberry Pis are even more power efficient because they don't have a screen. The screen itself, can take up some power. Yeah, but they were better planned. They were better executed. Any other questions? No other questions? Well, we got some time to get back to our usual stuff, so we'll kind of ease our way back into the boring stuff. So if you're wondering about the answers to exam 1, it is already on YouTube, so go to YouTube and check it out. I recorded that one on the night before SF Hacks, because I knew I wouldn't have time the next day. I mean, if you know the back end or the API of Canvas, you have a lot of potential of working with a publisher. Okay, think about the book publishers like McGraw-Hill or whatnot. They want to be able to interface with Canvas, so that the publisher can have their own exercises and material to distribute, but it integrates into an LMS like Canvas to make things kind of more seamless to students. So that's another example of why API is so important these days. All right. Okay. So we were talking about propositional logic. More tabs. All right. So last time, I'm gonna put up this part first, just so that we can ease back into the topics that we were talking about before the exam. We were talking about resolution. We also talked about CNF, conjunctive normal form, and then we got a little bit into proof by contradiction. So now we have three major components. So let me just kind of go back and re-describe those three major components, and then we'll talk about why they are related. The first one was resolution. Okay, resolution itself is no more than just kind of a template. Okay, so let me go back to the template here. So resolution is basically saying if you see something in this form, okay, if you see something like this form, phi or psi, and not psi or rho, okay, which basically means you have a sub-expression in two disjunctive terms where one side has the non-negated subterm, the other side has the negative subterm, and these two disjunctions are ended together, then you can quote unquote simplify. Okay? Then you can simplify to just psi or rho. The phi, this is phi or rho. So the psi component is completely gone. Okay? I call this a simplification because now you have one fewer sub-expression. Is that okay? So that's the idea of resolution. So resolution is really just this part. Okay? This part is the whole idea of resolution. It's just logic. The rest of this is the proof of resolution, the mechanism to make sure that it does work. Okay? So the rest is really the proof of resolution that it does work. Okay, that's the first part. The second part is CNF. So when we talked about CNF, okay, I think this is the section for CNF. So CNF, okay, I actually have to back up a little bit. So the discussion of CNF is right here. So we basically redefine. Oh, okay. So we basically redefine. Okay, it just moved the page. Let me go back to where we're supposed to go. Back here. There we go. So we basically redefine what is well formed as a well formed formula. And using this definition, a well formed formula is going to be a disjunction where each term in the disjunction can be a constant, a variable, the negation of a constant, or negation of a variable. Okay, if you have a big or small or with only those terms, it's not well formed. But that's the only well formed formula that we are going to use. Is that okay? Why do you think this connects to resolution?
It lets you remove the and from any statement.
We remove the and from the statement because every true statement or true well-formed formula inside the system, they are implicitly joined by and. Okay, let me say that one more time. Let me see if I can explain that a little better. There are two things that we have to talk about. One kind of brings us all the way back to general propositional logic. So when we go back to general propositional logic, we have to look at iota here. Okay, so when you look at iota, this is a set of well-formed formulae that are known to be true. But what I did not mention here is they're all true at the same time, which is kind of implicit and kind of understood, but I will have to emphasize it now. Okay? That your iota consists of well-formed formulae that are known or given to be true, and they're true at the same time. Is that okay? So that means there's an implicit conjunction amongst all of the well-formed formulae within iota. Does it make sense? So now we get back to what we are now talking about. What if a well-formed formula is always going to be a disjunction of variables, constants, negations of variables, and negations of constants? And all of those are true at the same time if they are inside the iota. What do we end up with? We end up with a CNF. Because each term is a disjunction, and because they're all true at the same time, they're all ended together. So the iota set itself can now be represented by a CNF. Yep.
I have a question about iota. So
Mhm.
is it
only well-formed formula or well-formed formula and axioms?
Kind of both at the same time. In the more traditional propositional logic system, then we'll also have the other ones. Okay? But in the case, in the ones that we are talking about, then you don't need the axiomatic ones. Because the axiomatic ones are very simple to express anyway, because you just have true, true or false, false or true or true, not false. Those are the axiomatic truths. And those do not really need to be expressed any further. Okay? So are we okay so far? Establishing the connection between resolution, which is kind of like a mechanism to simplify things, okay, to come up with a new term, and the concept of CNF, conjunctive normal form, which is a very convenient format to apply resolution. Because CNF says everything is or, and, and, or, but that's what we need to apply resolution. So there's a connection between these two. Are we good so far? Okay. The third one, which does not seem to be very related, is proof by contradiction. So let's take a quick look at proof by contradiction. It's in the same module, just at a slightly different place. So proof by contradiction is all the way down here. And when you look at proof by contradiction, we'll just focus on the very result here. This is what, okay, keeps changing because it's a little bit slow. Okay, there we go. This is the essence of proof by contradiction. So before we talk about this expression, we kind of have to know what the symbols are representing. What psi is representing is everything that we know is true to begin with. It's given to be true. All the axiomatic given truth is combined into psi itself. Is that okay? And psi itself is in CNF because this is basically just a conjunction of everything in iota. Are we good so far? What psi is representing? Okay. What phi is representing is the theorem that you are asked to prove. Okay? So we're basically given a whole bunch of stuff that is known to be true, and now we have a new well-formed formula, and you ask, well, is that well-formed formula phi following that whole bunch of stuff that we were told to be true, which is summarized as psi? That is the problem that you need to solve. Okay? Proof by contradiction says if you negate the theorem that you are asked to prove, and you end it using conjunction, you end it with psi, which is everything that you are told to be true. Okay? If that conjunction somehow implies false, then you have just established that phi is in fact a theorem. That is proof by contradiction. Is that okay? Remember last time we used the pigeonhole principle as an example, right? So that's an application of proof by contradiction. The theorem in that case, okay, what is the truth what is told to be true in that particular case? That we have more pigeons than there are pigeonholes. That would be psi, okay? What is the theorem? The theorem says after all the pigeons come home, at least one pigeonhole is going to have more than one pigeon. That is the theorem, okay? So how do we prove it by contradiction? We first negate the theorem, okay? What is the negation of, in quotes, okay? What is the negation of at least one pigeonhole has more than one pigeons? The negation is every pigeonhole has at the most one pigeon, right? We can allow 0, okay? It's just no more than 1. Why do we have a contradiction? Because if each pigeonhole can only have up to one pigeon, then the total number of pigeons that we can have is the number of pigeonholes, right? But we were already told that the number of pigeons is more than the number of pigeonholes. Well, one cannot be less than or equal to the other one, while at the same time greater than the other one. And now we have our contradiction. And because we have the contradiction, that means the theorem itself is true. Because we have proven, okay, in a very loosey and casual way, we have proven that whatever is given to you to be true, quote unquote, does not jive with the negation of the theorem. So do not use that term in your actual submission of any kind in this class. You know, if you just say that this statement, this expression does not jive with that expression as an answer, I will ignore that. But that's kind of one way to understand how it works. So is that okay? But how does proof by contradiction work with resolution and CNF? Yep.
If you get any contradiction in your big CNF of all of your well-formed formula, then all of it's a contradiction, and so then you know that your conclusion, the negation of your conclusion can't be true.
Exactly. So the first piece, okay, but before we can get there, the first piece is to say, this looks like a micro CNF to me, in a way, okay? Because, hey, this is psi, and here's a conjunction, and this is not phi. But wait, oh man, what if what phi is a whole bunch of it, is a complex expression? Well, so here comes the next part. The next question is CNF complete? In other words, if I start with any Boolean expression, okay, go back to your C program, okay, pick out any condition that is Boolean, okay, and then you ask yourself, can I re-express this condition as a CNF? That's the question that I'm asking. Is that okay? Does everybody understand what I'm talking about? Go to any program that you have written, CISP 360, 400, 430, doesn't matter what it is, okay? You look at the condition of a loop of a conditional statement of the first part of a ternary operator. It doesn't matter either. And then you ask the question, can I turn this into a CNF? That is what we're asking. And the answer turns out to be yes, okay? If you give me any Boolean expression, there is a way to turn it into a CNF. That is cool. That means it doesn't matter what you tell me is true to begin with, what is given to be true, what is axiomatically true. I can turn that into a CNF. Might be wrong, maybe complex, but it is a CNF. Whatever theorem you want me to prove, okay, I first have to negate it. But the negation of the theorem can also be converted into a CNF. Because CNF is complete. Is that okay? What happens to a CNF and another CNF? Okay, let me use another phrase to ask the question, and then the answer is going to be obvious. Okay? What is the conjunction of two conjunctive normal forms? It is also a conjunctive normal form. Okay? Oh, that is cool. Because now we look at psi and not phi, it is a CNF. Okay? And we wanted to imply zero. Where did we see implication today? Resolution. Okay? So resolution has implication built into it. Let me show you where that thing is. So we go back to resolution. Okay. See this implication here? We got implication. But then somebody's going to say, well, yeah, it does have implication, but it's not going to imply false. Well, I beg to differ. It can imply false. What if phi and rho in this particular setting are both false? Then you have false or false, right? Does that make sense? Okay. That actually does make a lot of sense, doesn't it? Okay? Because if phi is false and rho is also false, then we are really dealing with just psi and not psi. That you already know has got to be false, right? Okay, so now we have all of these major pieces. Okay, then we take a step back because we were looking at tree branches. We take a step back and look at the entire tree. Go like, how do these tree branches connect to each other? What is the trunk of this entire thing? That's what we'll have to remember. Well, what we're dealing with here, okay, let's go back to CNF first. If I give you a finite number of variables, okay, how many disjunctive terms can you possibly come up? Let's say we have 5 variables, P, Q, R, S, T. How many disjunctive terms can you come up? Like P or Q is a disjunctive term, not P or Q is one disjunctive term, R and T is one disjunctive term, and so on. Okay? How many can you possibly come up? How many possibility is there to one variable in a disjunctive term? It can be there, not negated. It can be there, negated. It can be not there. Right? So you only got 3 choices for each variable in the disjunctive term. So now the question is, how many possible disjunctive terms can we come up when we have 5 variables, P, Q, R, S, T? We have 3 for P, times 3 for Q, times 3 for R, and so on. So it's 3 to the power of 5. Okay? Not a very small number, okay, considering we only got 5 variables. Okay? How many ways can you connect all of these different terms in a disjunction? So you look at 3 to the power of 5 disjunctive terms, right? And then you ask the question, how many ways can we combine these things in a CNF? Well, when you look at each disjunctive term, it's either in or not in a CNF, right? So how many possibilities are we talking about? Well, a disjunctive term is either in or not in, right? 2 possibilities. So whatever number of disjunctive terms we can come up with, 2 to the power of that thing is the total number of CNFs that you can possibly generate out of any system. Okay? Are we talking about a small number? Nope. We are by no means talking about a small number. But the next question is the most important one. Okay? We still got 2 minutes. So what we are talking about here is if you take the number of variables, 3 to the power of the number of variables is the total number of disjunctive terms that you can possibly get. Okay? So if you have P, Q, R, S, T, then this is accounting for, we can have P by itself, Q by itself, R by itself, we can have P and Q, we can have not P and not Q, blah, 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 blah. This is representing the total number of disjunctive terms. Without taking any logic into consideration, without any constraints and whatnot, this is now representing the total number of CNFs that you can possibly generate in using only 5 variables. It's not a small number, but the point is, it is finite. Okay? So that means the number of well-formed formulae within a system like this is finite, which is a big plus. Because in conventional propositional logic, you can say, P or not P is true. You can generate it out of thin air just like that. Okay? But the worst part is, yes?
That's the equation that explains the number of conjunctive normal form?
Possible conjunctive
given the number of variables.
Given 5 variables.
Well, it just says number of variables, so however many.
Yeah, this is the number of variables. So PKRST would be 5.
Okay.
Yep. But in the old conventional propositional logic, you can have an infinite number of well-formed formulae. Because you can say, P or not P is guaranteed to be true. Yes, we know that, okay? So is P or not P and P or not P. I mean, that's also guaranteed to be true, right? So you can use a production or rule to keep appending P or not P to a conjunction and make it infinitely long. Is it well formed? Yes, it is. Is it useful? No, it is totally useless. But it will still give you a space that is infinitely large, which means you have that problem of, is that needle not in a haystack, or is it just that we haven't found it yet? Now, what if your entire space is only this big? It's now finite, right? So if you have searched through this entire space and you cannot find that needle, you can now conclusively say the needle is not in a haystack because I just searched the entire haystack. As opposed to, I cannot tell you whether the needle is not there or just that I have not found it because that space is infinitely large. Is that okay? So this is kind of a significant attribute of combining those three techniques. Okay, so this is just a little warm up of what we'll be talking about on Wednesday, when we get back and we will start to actually apply resolution using proof by contradiction on CNFs. So read ahead of me because I want you guys to kind of warm up back into these topics.